everyone, this is Miss Afric, and today we are going to be reviewing Unit 4, Part 2. Alright, so Unit 4, Part 2, that involves graphing, square roots and cube roots. It involves solving equations with roots and exponents. We've got some function operations, multiplying, dividing, composition. There's domain and range, I know that can be tricky. And a few other things too, so let's get started. Alright, when it comes to graphing and finding the domain and range, luckily your calculator can do a lot of the work for you. Alright, so let's take a look. Go ahead and take those calculators out. And I'll do the same. Alright, so graph the following, find the domain and range, show your table. So the table is what we're going to use our calculator for. Alright, so in my y equals button, I'm going to type this in, 2, the square root of x plus 4, move out, and then minus 3. Okay, then I'm going to go straight to my table. Alright, now it helps if you at least know where to start with this table. And the place we start with for square roots, our starting point, comes from these two numbers here. Alright, the number inside is opposite, the number outside is the same, just like always. So that would be the point -4, -3. Alright, now for square roots, that's where we start, because square roots only have one side. You'll see for cube roots, that's just our middle value. Okay, so I'm going to move my table up to the point -4, -3. Oh, there it is. Alright, and I'm going to get just two more points, -3, -1, and let's see, 0, 1. Alright, and that's enough to plot and graph. -4, -3, -3, -1, and 0, 1. Now this makes like a line sticking out and then curving, and that's our graph. Alright, then since it's an even root, a square root is an even root. Any even root will have domain restrictions. So down here, oops, well I put my table over there, but you get the gist. Alright, down there it says domain and range. Well, I always start by saying all reals. And when it's an even root, that just means that I have a restriction. I can see based on my graph, right? X has to be -4 or bigger, so X has to be greater than or equal to -4. Range, that's Y. Y has to be 3 or bigger, so Y has to be greater than or equal to 3. And that's all there is to it. Alright, cube root, very similar. Okay, I'm going to go ahead and type it in my calculator in my y equals. Now, cubed root is a little different in terms of how to type it in. We can't use a square root. So to type in a cube root, I'm going to go into math, and then cube root's number 4. Alright, so cube root, whoops, I was supposed to put a 3 in front. 3 times the cubed root of x plus 2, and then move out of it, and then plus 1. Alright, and once again, I'm going to go straight to my tables. Now, once again, that key point here is -2, 1. But that's our middle point for these, because there are points on both sides. Oops, positive 1, -2, positive 1. Since it's a cube root, odd roots have points on both sides. So in my graph, or my table, sorry, I'm going to go to -2, and I'm going to pick 2 points above and 2 points below. So -1, 4. And above there's -3, -2. And then I'm going to have to scroll for those other ones. So I'll scroll down first. There we go, 6, 7. And then if I scroll up, there it is, -10, -5. Alright, once again, plot those points, -10, -5, -3, -2, -2, 1, -1, 4, and 6, 7. Alright, and this is just kind of like a double of what we just drew. Alright, both sides. Now, odd roots, this is an odd root. Okay, odd roots have no domain restrictions, domain or range for that matter. So my domain is all reals, and my range is all reals, and I don't have to worry about restrictions. Alright, that's all there is to graphing. Next, we're going to do some function operations. So that's addition, subtraction, multiplication, division, and the last one, the hardest one, composition. Alright, so letter A is just addition. Addition's nice and easy. Adding, we're just going to add those two, f of x plus g of x. And since these are not like terms, I can't actually add them anymore, so that's my answer. Now it also says to state the domain. That is usually the hard part. So let me just remind you of two important rules. Number one is if there's an x in the denominator, we say the denominator can't equal 0, because you can't divide by 0, right? Makes sense. And number two rule is if there's an even root, we say x has to be greater than or equal to 0, because you can't take the even root of a negative number. Go ahead, try it. It wouldn't work. All right, so in this case, this 1/2, that 2 being on the bottom, that's actually the square root of x, all right, with a 2 here. So that's an even root. So since it's an even root, I'm going to say my domain is all reals, but x has to be greater than or equal to 0. Okay, subtraction's the same thing. We just set it up. One thing to be careful of is make sure you subtract the entire thing. All right, we tend to forget that. Here they're not like terms, so that's as far as I can go anyway. And my domain, again, start with all reals. Once again, I have that even root, so x has to be greater than or equal to 0. All right, now we start getting into the harder stuff. So letter C, that's multiplication. So that's 4x to the 1/3 times 8x to the 1/2. So for the 4 and the 8, we just multiply. That's 32. But for the exponents, remember, you have to add those. 1/3 plus 1/2. So in my calculator, you would do that, and you should end up getting, whoops, there we go, 5/6. Okay, then once again for my domain. All right, one thing I forgot to mention before is make sure you look at the originals and your final answer in order to figure out if you need a restriction. And remember, the only things that would make you need a restriction are an x in the denominator or an even root. Okay, I don't have x in the denominator anywhere, but once again, I have these two even roots. All right, so that means I'm going to go with reals, but x has to be greater than or equal to 0. All right, for D, same idea. I'm going to divide now, though. So 4x to the 1/3 divided by 8x to the 1/2. So again, these two, I just divide, that's 1/2. But these I have to subtract, 1/3 minus 1/2. All right, that's going to get me negative 1/6. And we can't have negative exponents. That means it has to go to the bottom. So it'll be 2x to the positive 1/6. All right, then my domain, once again, start with all reals. Okay, let me scroll so this doesn't keep blocking you. There we go. And again, we're looking for x in the denominator, which I have, and even root, which I also have. So based on how x is in the denominator, I know x can't be 0, and x also has to be greater than or equal to 0. So you could say x is greater than or equal to 0, and x can't equal 0, but there's an easier way to write that. Just combine the two by taking away this equal to. Then it's just x must be greater than 0, and that's our domain. All right, last one is composition. Composition can be a tricky one for some of us, so let's pay attention. All right, for composition, I always like to write my outside function first, 4x to the 1/3, but we're going to write it without x. So I'm just going to put a parenthesis there, because whatever your inside function is, that's going right inside. So in this case, 8x to the 1/2. All right, then we can use our exponent properties, distribute that exponent for 8 to the 1/3, x to the 1/6, because you multiply, distribute means multiply. All right, if you type this into your calculator, that's like saying the third root of 8. The third root of 8 is 2. So 4 times 2x to the 1/6 is going to give me 8x to the 1/6. And once again for my domain, make sure you remember to look at the original, the two originals, and your final one. All of that just has even roots, it looks like. So I'd say reals, x must be greater than or equal to 0. All right, so that was graphing and function operations. Just a few more topics to go. All right, let's try some solving. We've been doing a lot of solving, so hopefully this stuff is going to seem familiar. Okay, with solving, we do reverse PEMDAS. So I'll make a note of that because I know some of us forget. All right, so I'm going to start with addition and subtraction, multiplication and division, exponents, and parentheses. So here I've got a plus 5, that's addition, subtraction. Get rid of it. Alright, that gives me 243. Then we do multiplication and division. And after that we do exponents. Now here's the part from this chapter. To get rid of an exponent, you do the reciprocal. Or a root, but when it's a fraction, the reciprocal is a little easier. Okay? But wait a second. The most important thing. When you do an exponent with a root in it, you have to check to see if you have an even root. Alright, remember, root's the one on the bottom, and if it's even, do you remember what that means? Plus or minus. Alright, so for this one, I'm going to end up with x plus 1 equals plus or minus, and then you can use your calculator to help you out with this if you need to. Let me clear out of this. 81 to the 3/4. 27, so that's plus or minus 27. And then I subtract 1. So that would be negative 1 plus 27, which is 26. And negative 1 minus 27, which is negative 28. Okay, now notice how it says to check for extraneous solutions. You really need to make sure you do that. But I trust that you know how to do that, so I'm not going to go over it with you. Alright, you need to make sure, though, that you are checking your answers. Okay, because you can get extraneous solutions here. And that would stink to do all the hard stuff and then still get it wrong. Okay, alright, a few more. To get rid of a cubed root, we just cube both sides. And then you would finish solving from there. Alright, so subtract 10. And divide by 5. And that should give us 23. Once again, make sure you check. Okay, I've already checked, so I know it works, but you need to make sure you check. Alright, a few more. Here I'm going to divide by that 4 first. So x to the 1/2 equals 3. I'm sorry, 1/5 equals 3. And then once again, when I have that fraction, I use the reciprocal. Alright, so we end up with x equals 3 to the 5th, which is 243. Again, check, because I know it works, but you might not. Alright, last solving one, it's the hardest one. Alright, here I'm going to get rid of that square root by squaring both sides. But remember, on the right side, that means I have to multiply it twice. X plus 2 times x plus 2. You got to FOIL that out. So this is going to be one where we have to factor. Alright, 2x plus 19 equals x squared plus 4x plus 4. And then from there we got to get it to equal 0. So subtract 2x and subtract 19. Alright, we end up with x squared plus 2x minus 15. And from there we've got to go through and factor it and then finish solving. Okay, I know I'm going a little fast, but if you have questions, just make a note in your notes, pause, make a note, and then make sure you ask in class. Okay, now once again, you really got to check these, because actually, there's always a good chance one of these don't work. And in this case, it's negative 5. Not going to work. So just positive 3 is my answer. Alright, one last example, and then you're off to try these on your own. Okay, finding the inverse. Finding the inverse, that's 2 steps. Switch x and y, and solve for y. Alright, so I'm going to do just one of these. Okay, and I'm going to do actually this one. So, switch x and y, that's my first step. And then to solve for y, we just again do reverse PEMDAS. So, x minus 1 equals 3y to the 4th. Divide by 3, I've got x minus 1 divided by 3 equals y to the 4th. 4th root, and that's even, so plus or minus. So my final answer here will be plus or minus the 4th root of x minus 1 divided by 3. That's equal to y. Alright, and there you have it. Again, I know this was speedy. Write down any questions you have. Make sure you ask in class. I'll see you later.